Gauss Jordan method, which is also an example for direct method. This modified form of Gauss elimination method, here the mathematician Jordan suggested that why the matrix A, which is the coefficient matrix, is only reduced to upper triangular matrix. It will be even more time saving if you reduce matrix A to a unit matrix or a diagonal matrix. That is, instead of just making elements below principal diagonal elements as 0, if you reduce matrix A to a unit matrix or diagonal matrix by making all elements above and below the principal diagonal of A as zeros, then we can reach the solution even more easily. This method will save back substitution time, although number of row transformations will be a little more compared to Gauss elimination method. Let us look at an example. Here we have been given with 4 set of linear equations and we have 4 unknowns to be found, x, y, z and w. First step will be to write the matrix form of linear equations Ax equals b, where A is the coefficient matrix, which is obtained by looking at the coefficients of each variable of each equation. After that we have column matrix X, which is the solution matrix x, y, z, w, and we have B is the constant matrix, which is obtained by looking at the RHS of each equation. In the next step, we will write down the augmented matrix A/B format. We will apply row transformation in augmented matrix so that coefficient matrix A can be reduced to a diagonal matrix. We have written augmented matrix where this is the coefficient matrix and this column matrix is the constant matrix B. We have principal diagonal or main diagonal marked. Our intention is to make every element below and above this principal diagonal as 0 for the augmented matrix. Or we wish to make every entry below and above the principal diagonal as zeros for the coefficient matrix A, which is equivalent to making matrix A as a unit matrix or diagonal matrix. If we make use of row transformations, R2 such that 2 times R1 minus R2, R3 such that R3 minus R1 and R4 such that R4 minus R1, we are hereby keeping row 1 as fixed, and depending on these row transformations performed, we will get the new matrix, which is the updated augmented matrix. Let us discuss one row transformation. R2 changes to 2 times R1 minus R2. That is, this entry will change such that 2 times 1 minus 2, which becomes 0 here. 2 times 2 minus 3, that is 4 minus 3, which becomes 1 here. 2 times 1 minus of minus 1, which becomes 3 here. 2 times negative 1 minus 2, which becomes minus 2 minus 2, which becomes minus 4 here. 2 times minus 2 minus 7, which becomes minus 11 here. Similarly, applying